This video will describe Among's architecture and the technologies it uses. In order to explain how Among works, we will walk through a typical usage scenario. The compliance officer, CO, of Piraeus Bank has identified a suspicious customer or potential customer using the bank's internal AML system. He wants to see whether this particular customer has also been identified as suspicious by Bank X, a fact that would support Piraeus Bank's information on the customer's risk. Risk is determined through a risk score, which represents the degree of suspicion in which the bank holds a customer. The compliance officer sends a request to Bank X, asking for information on the suspicious customer using a unique identifier such as the customer's tax number. Bank X then responds in one of two ways. Bank X can return no information. This means that either Bank X has no information on that customer, or they fall beneath a commonly agreed risk threshold. This threshold stops banks from using Among to retrieve details unrelated to AML reasons. Otherwise, as in our scenario, Bank X will return information on the customer, including their name, date of birth, country of residence, and risk score. The compliance officer will then perform a manual check on the personal details to confirm both banks are referring to the same person. Finally, the compliance officer will investigate the case and report any fraudulent activity to the authorities. GRIA is a service-oriented grid infrastructure designed to support business-to-business collaborations through service provision across organisational boundaries in a secure, interoperable and flexible manner. GRIA forms the foundation of Among. GRIA was chosen for three reasons. Firstly, its strong support for security, involving public key infrastructure and encryption. Secondly, its support for service-level agreements, or SLAs, which are used to control access to and charging for Among. Finally, its open source license. GRIA is supported by the IT Innovation Centre at the University of Southampton. Service-level agreements, or SLAs, are at the core of Among and are used to ensure that banks cannot abuse the system, for example by using Among to obtain information on all a competitor's customers. SLAs control how many queries banks can perform, for example 100 per day. The SLAs are enforced via charging, so the rate for queries can climb as more queries are used. For example, the charge may be €1 for each of the first 50 queries, rising to €10 for each query thereafter. GRIA's inbuilt support for SLAs was enhanced with the SLA monitoring and evaluation component from the Being Grid project. This component automatically notifies subscribed parties whenever SLA constraints are broken. This is a screenshot from Among showing SLA usage. We can see there is a constraint of a maximum of 2 queries per day, of which we have used half. Cloud computing is the use of a hosting provider that delivers automated and near real-time arbitrarily large computing resources. Cloud computing was not appropriate for Among, which does not have large resource requirements. However, the ideas and even the components used in Among are applicable to cloud computing. Clouds could benefit from a grid trust and security solution, similar to the one used in Among. GRIA offers a dynamic security system for resources based on public key infrastructure, where rules defining client roles can be added and removed by authorised persons. In addition, static policies define what operations are available to given client roles on services and resources. Clouds already use SLAs to some extent. For instance, the Amazon S3 service uses a simple bilateral SLA agreement process with its customers. The terms used in cloud computing SLAs are generally high-level parameters such as CPU time, disk space, and monthly percentage uptime. In contrast, the GRIA SLA service is able to use application-specific metrics to monitor and manage the system. Being able to define and enforce such application-specific SLAs would be a great benefit to cloud platforms. Thank you for listening. For further information, please visit the Gridipedia website.